Welcome back to 9.6. This is part 2. We are going to talk about complex problems that you may run into in Chapter 9, Section 6. So, we'll kind of skip the warm-up just because hopefully you'll watch this soon after you did 9.6, where you're using angle of elevation and angle of depression. Quick little recap. That is when you start off looking at the horizon and you go up, that is an angle of elevation, or an angle of depression. You start horizontal and you go down, that's an angle of depression. These are the two key ideas to turn word problems into problems we can solve normally. Now, I would like you to follow along with this problem. I'm only going to do one problem today. The goal is to show you one that is more complex, but hopefully begin to help you think through how to solve these problems. I'm going to read it once, and then I'd like you to copy it down. So pause the video after I read it if you need some time to copy it down. Chase and JoJo are estimating the height of a flagpole from different locations. Chase sees it with an angle of elevation of 48 degrees, while JoJo sees it with an angle of elevation of 55 degrees. He is 10 meters closer to the pole. Find the height of the pole. Okay, so if you need to pause the video, do so, copy it down. This is going to be the only problem we're going to do for the second half of 9.6. I'm going to actually do it on a totally separate page. Hopefully you have that written down. I'll refer back to it in a moment. Let me write down the facts. If we are collecting fact finding, this is what we have. So we have Chase, who is, he has an angle of elevation of 48 degrees. JoJo has an angle of elevation of 55 degrees, and we're told he is 10 meters closer. And that's really all the details we have in this problem. So these are all the things I would have underlined in the question like we did before. Now, let us draw a simple model, just something to kind of represent what we're talking about. There's my flagpole with the flag. I'm going to put one here and one here. We're going to negate their heights. So we did one last notes that basically talked about we had to use someone's height to find the actual height of something. In this one, we're not given any of that, so we're not going to use it. Now, this is Chase, and this is JoJo. This is important. One way we know is we're told he is 10 meters closer. But also, we expect this to be a higher angle of elevation. You're going up sharper, so that if someone was standing right here, they would be almost a 90-degree angle of elevation. If you look over here, we have a 48-degree angle of elevation. So that is these two pieces. And like I mentioned before, especially while doing these problems, while learning remotely, there will be information I give you that you'll need to use. So you'll have to use everything I give you. So let's use the 10 meters closer. Well, we have two options. This is not 10 meters, but we know this is 10 meters right here, just between them. I don't know how far this is. I'm looking for this. I'm looking for X, we'll call. That is up and down. But I don't know this, so I'm going to add another variable, Y. I don't need Y to answer the question, but I'm going to use it to help me out. So I hope you are following along so far, just copying the diagram, because the diagram is a lot more of the problem than this. This is a lot of words. This doesn't help us understand how we use trigonometry, but something like this, a simple model in 2D space, is going to help us solve for this height. what we actually have are two overlapping triangles. What I'm going to do is draw them in separate colors over here. How about blue and orange, okay? So I'm going to draw what I'm going to call the Chase triangle over here. This is Chase's triangle, and then JoJo's is going to be over here. So Chase's triangle looks like this. I have the flagpole. The flagpole is not different. I have an angle of elevation of 48 degrees. And I have a bottom of y plus 10. Y plus 10 because it is this whole amount. Y is how close he is, but I know they are 10 apart. So I'm going to call this y plus 10. Okay? Not very promising so far. This was all I had. I can't solve this. This is two variables in one problem, so I can't solve it. Well, let me draw my JoJo information over here. Like I said, there are two triangles. This is 55 degrees. He is y away, and he is x tall for the flagpole. So once again, flagpole's here, and all that stuff. Let me take these colors and put them on our original graphic. Hopefully you have that. So the Chase triangle is this one, and the JoJo triangle is this one. They overlap, but they have the exact same x, and they use both part of this y. This actually is enough to solve it. Remember, we can't solve one thing with two variables, but two things with the same two variables we can solve. How? I would love for you to pause the video and try to solve it now. I think you have the capability to do something like this. I think you can combine the stuff we've done and problem solve to do it. So if you want to do that, give it a shot, pause for a few minutes, and try to work it out. But if not, welcome back. If you have, great. I hope you got it. Let's walk through what we're going to do. Let's move on to another sheet, but keep this one up here so you can still refer to it. I will continue to work in the colors. That way you can keep track of what's going on. Let's just set up a tangent problem. I'm not going to solve it. I'm not going to have an answer for it, but I'm just going to set it up. The tangent of 48, opposite over adjacent, will be x over y plus 10. I'll turn that into a decimal while I'm here. So either on your calculator or with your sheet, you can turn that into a decimal. 1.1106 equals x over y plus 10. Okay? That is this triangle. Working in blue on that side. And then I'll work in orange over here. And we have the tangent of 55 equals opposite over adjacent, x over y. And I will turn that into a decimal as well, just because that's one more thing I can do to make it not geometry anymore. It's just an algebra problem at that point. 281. I'm going to do 4 decimal places. While I'm solving it, even though my answer, I'll probably just do 1 decimal place for an answer. But while I'm solving it, I want as much detail as possible. So all I did was I set up these problems as if I was going to solve it, and then stopped when I couldn't anymore, x and y. Now, I hope you can look at this and know how to do it, how to solve this. Hopefully you can look at these two and solve it. What we need is 2 equations with a common expression, with a variable set up. So what I'm going to do is I'm going to turn both of these into this. X equals something. Because if x equals something over here and x equals something over there, I can put those two together. So what I will do is multiply by the denominator on both sides. Y plus 10. And then over here, it's just y. What that's going to do is isolate my variable. So I have x equals y plus 10 times 1.1106 and x equals 1.4281 times y. This side, very straightforward. This side, not so much. Not so much. Here, let's see if I can zoom in a little bit so we can get a little better view. No, we cannot. Okay. Quick note here, I'm multiplying by y plus 10. That is a polynomial. And so what I have to do is I have to distribute this throughout. Very easy thing to mess up. It's just a 1.11. It is an algebra rule that I have to remember. Plus 10 times this. I'm pretty sure I can do that in my head, but I will double check while I'm on camera so I don't make a mistake in front of the entire internet. 106. Okay, so we have two expressions, complicated, but they are expressions nonetheless. And those expressions, I can now set them equal to each other. I can set 1.1106 times y plus 11.106 equal to 1.4281y. This is solving two equations with two variables. I'm looking to set something equal, this time it was x, and what I'm going to get is y. Y is not the final answer. Remember, we're looking for the flagpole height. What we're finding is actually how far JoJo is to Chase. We could have done a little bit of moving around and gotten x by itself, y by itself to find x. But I'm okay if I find one variable and then I can just do one more step. So sometimes the easy step will just eliminate itself to you, sometimes not. Okay, I'm going to subtract 1.16y on both sides. So I have 11.106 equals I get 0.3175y. And then all I have to do to get y is 0.3175. 3175. So y equals, I'm going to put that in my calculator, 11.106 divided by 0.3175 is 34.979. I'm going to round that right now to one decimal place and get 35. So let me go back, re-talk about all of this before we go on to our final step. I had our big, long amount of text. I had this, which I turned into a drawing. I turned it into this drawing. This drawing right here showed me we had one guy with one angle of elevation and another with another angle of elevation. All I knew was how far they were, but this actually is enough to solve it. So I set up two different trigonometry problems, one for each triangle that I have. So there's an orange triangle and a blue triangle. I set it up here and I set it up here. I couldn't solve one of these because I have two variables. I need to use two triangles to solve two variables. From there, I just did my normal trigonometric functions. I just set up the tangent is opposite over adjacent, tangent is opposite over adjacent. Well, I turned the tangent into the decimals just so I can use it now, and at this point, right here, it is no longer a geometry problem. From here on, it is only algebra, only things that you have the ability to do. After that, I isolated a variable. I chose x because it was one step to isolate it. You could, in theory, definitely isolate y. Sometimes this one looks a little harder to do that. I chose to isolate x because it was one step to isolate it. When I did, I had to make sure to look out for stuff like binomials being multiplied that we had to distribute. This one didn't. This one was much cleaner because there was no plus anything on the denominator. And so I end up getting x equals something. It's the same variable, so I know these are going to be set equal to each other. And then I solved it to get y. And what I actually just found was this. I found how far JoJo is from the flagpole. All I'm going to do to answer the final question is use that y and do my original trigonometric problem. So let me see if I can show everything at once. Great. I'm going to refer back to my orange triangle. Part of this is knowing what you have and how you're finding things. X, Y. So remember, that was my orange triangle that I was given earlier. I just found out y is 35. And now it's a very straightforward trig problem. I'm just finding the height given that he's 35 away and he has an angle of elevation of 55. If you can't tell where this is coming from and like what we're using this for, I can almost hear some of you saying, when will I ever use this? The point is you may never use this, but people do use this. Using trigonometry helps you find locations in space with not having everything. Perhaps it is prohibitively too far to measure this distance, but if you have two satellites and you're dealing with light years away, these are the kind of problems that you can solve with little information. So it is very important when we're establishing where we are in space. And I'll solve our final problem to get an answer. Tangent of 55 equals opposite over adjacent, 30x over 35. We've already written this before. We did it earlier up here when we did not know what y is. And then so now I'm just going to type 35 times the tangent of 55 into my calculator, and it's going to give me the answer. 35 times tangent of 55. And I get 49.98. And that, if I want to round to one decimal place, that'd probably be somewhere around 50.0. And then in this one, it's meters. Okay, so that is an example of using trigonometry in a complex problem, a problem where you normally have to use two triangles. We're doing each of these twice. So you're doing something with multiple variables, and what you're going to end up having to do is set those variables equal to each other in some ways. You're going to have to isolate them, one of the variables, and then set those to match. That'll give you the other one, and then you'll be able to solve it. In this one, I chose to match x. There is a way you could have found y. I would look for the most straightforward way to match it, and that way you're doing maybe a longer problem, but each step is a little easier. Drawing the picture was crucial. Drawing the picture was how we figured out what we're talking about. We're talking about two triangles, a blue triangle and an orange triangle. I hope you know you're always welcome on tests and quizzes to bring in color things, highlighters, markers, and make these sort of diagrams. This is part of the problem. If I can teach you to take words and create models for them, that is one of the most important things you can do in math. So I hope that made sense. Make sure if that didn't, go back, rewatch the video. Our final answer was 50 meters. If you would like, try to do this again. Maybe change these two numbers. You'll have some homework problems as well that should be in a similar vein. They're not going to be exact, but they're going to be similar, where you're using multiple trig identities and complex algebra. Not technically complex, because that's an actual thing in algebra, but you're using complicated algebra to end up solving for a variable. All right, well, thank you very much. I hope this was of some help.